my name's Mick Byrne, and I'm going to be presenting on just to kind of talk about how we use Xamarin in our agency, because some of the challenges of doing agency app development are a bit different, and we've used Xamarin to sort of build apps that are better and build them faster. So We Make Apps is in Collingwood. We're on Wellington Street. If you spend much time at the Tote, you'll know us because we're just up the road. We've been in business since 2011, and we started off just doing pure native apps, so Objective-C and Java, and then Swift and Kotlin. In about 2015, prompted by one of our projects, we switched over to start using Xamarin, and we sort of haven't looked back. So since then, we've published apps for about 20 clients on Xamarin. So these are often public-facing apps published in the store. iOS and Android, we've got an app with a Windows desktop version from the same code base, a bunch of other things. So probably about 50 apps on Xamarin out in the wild. And interestingly, our very first app was in 2011, back in the monotouch days, for a little issue tracking and source control service called Unfuddle that's still around. I think the app is still in the store, but it is looking a bit long in the tooth now. So what I want to talk about today is the shtick is that building apps when you're in an agency is a bit different from, say, you're embedded in a corporate and you're building apps, internal apps for your own business, and how we've been able to use the capabilities of Xamarin, especially the code sharing capabilities, in order to sort of build really great apps with all sorts of different requirements, and internationalized apps, hardware integrated apps, all sorts of things, and how we've been able to use Xamarin to do that. I'm going to touch on some of the challenges we found with Xamarin, and I'm hoping you'll sort of, you might sort of nod your head when I talk about some of those. I've got a couple of case studies at the end if we get that far. It's not a big crowd tonight, and I'm more than happy for people to just call out questions as we go. I'd prefer you to sort of get as much out of this as you want, and I'm happy to let this presentation get steered by what you want to learn. So just talking about agency app development. When I talk about agency, we're sort of 10 people all together. We just build apps for other people. So we're not a publisher. Other people come to us with their ideas for an app. We don't do games, but we'll do anything else. Probably 2/3 of them are public facing, and the others are internal apps for businesses. But even the internal apps we generally publish on the store. Not always. We've got a few apps distributed through MDMs and enterprise development certificates, all of that sort of stuff. So the first thing about dealing with agency apps is you just have to deal with your client's requirements. And every project that comes to us tends to be totally unique from the last one. And we've had to build apps. We've sort of done a couple of apps now that use Bluetooth LE to control hardware. We've done every manner of location integrated apps with maps and pins. We've done augmented reality apps with image recognition. We've done some weird things where we've sort of dug in and done share extensions on iOS, so your app turns up in the Photos app as something that you can push one of your photos to, and we present an entirely custom interface to sort of post your photo to this sort of app. We've had to do audio and video. We've done a couple of chat apps that have been, really complicated with, tens of thousands of users, one-to-one chats between anyone. Payment systems, I mean, anything that you can think of. We've recently built a VoIP app, so on Xamarin, so with the SIP protocol, call kit, having to trigger and answer calls, hold and resume, all of that sort of stuff. The other aspect with the kind of apps we build is the expectations for the design of our apps are really high. Our clients expect their apps to look and behave like the most polished apps in the store. So a lot of the views are really custom. All of the transitions have to be really smooth. There's this tension between people wanting the user experience across platforms to be really similar. It has to feel like the same app, but at the same time, it has to conform to the platform paradigms. So using the back button in your Android app has to behave exactly as users expect it, and all of your swipe on iOS to return to the previous view controllers, all of that sort of stuff. Partly based on that requirement, and partly because we came from a pure native background, we don't use any kind of sort of common denominator framework, any kind of self-contained framework for the UI. So we don't use Xamarin Forms, and I'll be showing some solutions later on. So it's just Xamarin Android and Xamarin iOS and other frameworks when needed. And the other thing about agency development is we have a lot of things on the go at the same time. We don't have the luxury to just sort of have that one app and have a team on it just going, you know, working on that app for a long time. So we often have an app given to one developer who's expected to build both platforms at the same time. We've got constant support and maintenance of all of our existing apps. So we need to be able to have, it's vital for us that when you check out a project from source control, it should build and run first time. You should be able to publish the app without having to look up the to-dos in your source control and change any keys. And a developer should be able to open an app that they've never seen before and be able to find what they're looking for. One of the things that's a result of that is we're very skeptical of any third-party frameworks. So we've got a philosophy as few third-party dependencies as possible. We'll use a third-party dependency where it solves a problem that's really hard for us to solve, like dealing with the networking stack or downloading and caching images from the internet, but we won't use third-party components for sort of a little bit of UI, a nice calendar view. We'll do that ourselves, because once you use that third-party dependency, you crack open the solution 18 months later, that open source project doesn't build anymore, and the developers who put it on GitHub have just quit. So we find we try to boil everything down as much as possible. And I think I just gave this talk a couple of weeks ago in Sydney, and I came away with the sense that the way we do things at We Make Apps, I thought it was just the same, thought everyone was doing it like that, but I think it's a little bit different in that way. So some of the other things is we don't use interface builder for our iOS apps, and we don't use layout files for our Android apps. Everything's built in code, and the idea being that we want as few files as possible in the system, and we want those files on the two different platforms to align as much as possible. So it's more code to put together your UI, having to create each view in code and insert it into a view. But it means when you bring up your iOS and your Android solutions side by side, you can follow exactly what's happening in each solution the same. There's not a little bit of black box Android layout inflation going over there and some interface builder going over there on iOS. Oh, and cross-platform always. So we're completely platform agnostic. We don't preference iOS over Android, and all my developers have to be cross-platform developers. We don't have iOS developers and Android developers in our team. Everyone's expected to know both platforms. Right, so I hope that sets the scene for the kind of challenges that we're facing. They're fairly generic, but you know they've got their own characteristics. So the first thing that Xamarin obviously does is being able to share code across your two platforms, and that's the core benefit that we're able to do between those two platforms. What I've got there is we're using the clock command line tool, count lines of code, and it just goes through your solution and just literally counts how many lines of code you've got in all your different files. We've got a project called StorePlay, which is on iOS, Android, also a Windows desktop version, and we've even spun it up as a little headless .NET Core executable. This is an app that gets used by retail businesses to play like properly licensed, curated music. So especially popular amongst sort of fashion stores and hairdressers. And these stores get a player app, so they need to be able to just sort of plug in an iPod and have it running all the time. And these numbers here sort of demonstrate on each of those platforms, we're getting at least sort of 2/3 of our code across all platforms is shared. And the difference for us coming from Xcode, Android Studio, sort of Objective-C and Java days, I mean, it's just an enormous benefit for us. And a lot of our focus since we switched to Xamarin is trying to, you know, increase the amount of code that we're able to share across those platforms. The next bunch of slides I'm going to go through is all about how do we do that? How do we reduce the amount of code that's on different platforms? I mean, I'm not going to go, it's obvious if the code's in one place, you're not repeating yourself and you're not getting those problems when you need to maintain those apps. So the first thing we do, which I thought was completely normal, is shared projects in Xamarin. So we don't use PLC libraries. We just use shared projects where you just sort of, people need me to explain how shared projects work? I will anyway. So the beauty of the shared project is the code that's in your shared project just literally gets copied into your main project and it all gets compiled in one go. So we'll have an Android solution and an iOS solution. There'll be one project, which is this shared project, and it just gets copied into both of our solutions. So in that shared project, we're able to have all of our models, all of our networking code, all of our sort of non-platform specific stuff that we can define, like colors and fonts, all of our constants, all of that sort of stuff we can just have in one place. And it means we don't have to have that code in our iOS project, in our Android project. In our platform specific project, so you can see there's the writeon.ios, that'll have our platform specific UI code, sort of placing our controllers and our views and sort of putting all of the pixels on the screen, and all of the sort of guff you need, all of the sort of plumbing tools, your info.plist, your entitlements files. Same on Android, your manifest files, all of that sort of stuff. We also have taken this further and we've come up with a solution that lets us share the core UI elements between these projects. So you'll notice that in the shared project here, I've got a controllers folder and a views folder, and I'll get to that. I'll explain that. Another thing we do is linked assets. So for all of the images and the fonts and sounds, all of those sorts of assets that we need to share between the two projects, we store those in a folder in our shared project. And when we include them in our platform specific project, we just add them as a link to those files in through Visual Studio. And the files have to be in the bundle in iOS in order for the iOS in the resources folder in order for it to be able to pull them out and use them. And the same on Android. What this means is we don't use the XC assets system for storing images because you know, it's got its very platform specific JSON sort of stuff. Rather, we just sort of put them all in one place and link them in. There's a little bit of plumbing we have to do when we want to pull one of those images out to sort of, you know, match up the @2x and @3x on iOS and sort of futz around with it on Android. But it's simple code. It took us a day to write, and we're able to do that in the future. The only exceptions to that are our app icon and our launch screen images in terms of assets. So, you know, we put those in that we use our XC assets folder on iOS, and obviously we want to have different app icons as well across the two different platforms. The real the thing that we've come up with to really sort of leverage what Xamarin can do is a little framework that we built called XPLAT. So this is something that we've built ourselves, and the intention of XPLAT is to share the core UI code across the two platforms. The goals of the XPLAT system is to make it really easy to do the simple and common stuff, to have a central location for your sort of business logic related code that interacts with the UI. So when a user taps a button and we have to make an API call and return some models and then, you know, hand it back, XPLAT lets us do that by splitting the controllers off two files. What it doesn't do though is it's not a self-contained cross-platform UI framework. So we don't actually, we don't create a button that's just the lowest common denominator version of a button. We create an object that implements an interface that our shared code can understand, but in the platform-specific code, it sort of turns it into the native version. I've got a demo coming up and I'll be able to sort of explain what all this is. Just sort of setting the scene. I know it probably sounds a little bit hard to follow. Why don't I bring that up and you can actually see what I'm talking about. So that's my Android version. Can everybody, is that code big enough? Can people see what I'm doing here? Where's my mouse? All right, so I've created a really simple app here. I'm just going to run it so you can see exactly how sort of simple it is.
Actually, yeah, just enlarge it a little bit.
Mm-hmm. So this is my simple little app with a little fun colouring in pug and a button to push to another controller and a button to pop open an alert. So I can click on that, it takes me to some other controller. I've just got a button to pop back. This is sort of like super simple, and you know, you could probably get away with lots of other frameworks to do the same thing. I just want to demonstrate how it sort of works. So in my shared project here, in my controllers, I've got my main controller, and this is the controller for this screen that we see here. So the key thing here is that we use partial classes. And so a partial class is just where you split the code for one class across two files. At compile time, it just takes all of the files you've got that are marked as partial, and it just sponges them all together, and then it compiles it. What I have here is I've got my main controller.cs in my shared project, and it's, and over in my iOS specific one, I've got the iOS version of this controller, which is also a partial class. Over on my Android version, I've got the same thing. So you can see this shared code here. This is actually the same code in both solutions, and it's got its main controller as well. The key thing we've done here is this view controller. So this is inheriting from a base class. Sorry, that's over, which is also a shared class, and it inherits from this XView controller class that we've created. This XView controller is what lets us sort of treat have these two the controller across both platforms in the one place. One of the real challenges we found once we started doing Xamarin was aligning the behavior, the life cycle of UI view controllers in iOS and on Android, whether you're using fragments or activities. And aligning those two different life cycles is a massive challenge, because if you're not able to kind of have a shared life cycle of events, it sort of defeats the whole purpose of sharing all of this code in the first place. It's one thing to share your networking code and your models code, but we want to share the business logic in our controllers, the business logic behind our UI controllers. Is this making sense? Is everyone following? I know it's sort of not obvious at first. I'm just going to show you the code in the shared controller class. So it defines the internal UI elements. I've got an image view, which is our little fun pug, and a couple of buttons. The constructor's empty. And then in the view lifecycle, we have this onView loaded shared. And so this is part of the XPLAT controller that we've created. The idea is that the native one will get called first, the shared one will get called first, and then your native one will get called. So what I'm able to do is I create all of these views, and I create them using a sort of factory method. This create view method here, under the hood, we've got these compiler directives that are saying, oh, I'm in iOS land, so I'm actually going to be creating a UI image view, and I'm going to be wrapping it in this X image view class, this cross-platform class, which implements this I image view interface. I can set some really sort of basic common properties here. So I can set what image is it actually from, and this image from bundle is grabbing my asset out of the resources folder here. I can set a scale mode. Same with the buttons. I can set sort of text, colors, action, corner radius, border width. But what this doesn't do is it doesn't attempt to implement everything that you can do on iOS and Android. If I wanted to add a drop shadow to this button, I'd have to do that in my platform specific code, because that's implemented quite differently on Android and iOS. You know, iOS, you drop into your CA layer class, and then you add all of these shadow offsets with CG colors. And on Android, you create all of your shape drawables and all of that sort of stuff. So we sort of like going back to that philosophy of we'll do the simple, common things. We'll make that really easy to do. But if you want to do any sort of fine-grained UI work, you have to drop into your platform-specific code. And it's all about, we want to build the app quickly, but we also need to be able to make it exactly the way we want it, sort of really platform-specific UI. So this sort of creates all of these views, but importantly, the shared code doesn't actually place the views on the screen. Shared code doesn't do anything with actual, pixels on the device. All of that gets done in platform-specific code. So when I switch to my platform-specific main controller, it's got an on-view loaded native. And by this time, all of my fields, this is a partial class, so it's got access to private variables. And it's got this, all of our I image view, all of our interfaces, our cross-platform image views, they've got this as native method. And this kind of casts that object back to its native implementation. And suddenly my object has got access to all of the platform-specific things. So I can set my shadow offsets. I can, do strange things with setting the font of the placeholder text. I can start to do weird events related to keyboard handling that are always very platform-specific code. So it's all of that stuff that's really hard to do. And the two platforms do it really differently. We don't try to come up with a one-size-fits-all. We let our developers do the UI stuff on the platform. The most important thing it does is this is where I actually place the stuff on the screen. Now I'm just using really simple frame-based layouts on auto resizing masks, but this is where you would otherwise use your relative layouts on Android, or you would use your layout constraints on iOS. That really platform-specific stuff, that all gets done here. So here I'm just adding them all into the view, setting sort of, width, height, X and Y, that sort of stuff, which places them on the screen.
Sorry. How does it know whether it has to invoke, conditionally, it gets compiled into one unit? Like this overload, this override on view load native, how does it know that it has to execute this block for iOS or this block for Android?
That's all coming from this XView controller class. This is under the hood. This class has got a whole bunch of if __ iOS compiler directives and if __ Android directives, and it's implementing it that way. Does that make sense?
Kind of. Maybe we'll have to look at the Android version of it.
The Android version looks exactly the same. On view loaded native, it's got the same method name, it's implemented the class, and it's adding its views, but it's just doing it with it's using it. It comes with a frame layout as its root view, and then it just sort of, here I'm just adding them with frame layouts. Normally here you'd put in a linear layout or a scroll view layout, and you'd implement all of that platform specific stuff. Okay. The idea is that in your shared code, the only UI elements that you're interested in your share codes are the ones that the user actually interacts with. All of your sort of ancillary views that are used to sort of space things and put things around, that's all platform specific. So we'll do that over on the specific platform. And one of the things was, there's no, particularly with your collection views and your really complex recycler views, they're implemented on iOS and Android kind of differently. You could probably work really hard and come up with a cross-platform version, but we just sort of feel like iOS has got a great collection view. It does everything in its own particular way, so you just implement that on your platform-specific stuff. In your shared code, you'll have the cells that appear in your collection view, they'll be shared, and the buttons and the labels that appear in those cells will be shared, so you only have to set those values once. There's something I want to talk about, which I'll come back to, about why we made a decision about the differences in those two sort of platform life cycles. The one thing my shared code does have, though, is this is where I can do all my button handling, my UI event handling. So we've just got an actioned property, and it's just a simple event handler, and that's down here. And when my push button gets tapped, I just create an instance of a new view controller, and I just push that controller into my navigation controller. And this is shared code. This is exactly the same code on both platforms. Our XPLAT system is sort of helping us handle that and do it in a platform-specific way. But for the developers who were building this stuff, they're able to sort of handle all of this stuff in the one place. I'm just going to jump back to my presentation now, because there's a, yeah?
So the XPLAT idea is you create a project that is your XPLAT, and it's specific to that app.
XPLAT is a nugget. We just have it, it's a completely self-contained, sorry, NuGet. I'm so used to saying, I still think it should be nuggets, but anyway, yeah, and we just put that on our own little private NuGet repository, and it's just included as a package. So up here in my packages, I've got the WMECapps.xplat, and that's it. And all of these sort of base views, it's not that big a deal. It's clever, but it's relatively small, because it's not trying to, this package doesn't actually, like I said, doesn't put any pixels on the screen. It just lets you create these XPLAT views and these XPLAT controllers. They're just wrappers around the native implementation, the views, the UI view controller on iOS, and on Android, we just actually ignored fragments and activities, and we just built them ourselves.
Do you end up pushing a lot of stuff back into that project? Like when you work on customer engagements, is it fairly stable, your XPLAT?
Yes,
yeah.
It's very stable. It was in flux for the first 2 or 3 projects, and now it's just fine tuning, it's just tightening the screws. And it really, because of this guiding philosophy, we've constantly got my developers saying, oh, it'd be really good if XPLAT, did this other thing, which, it's there on both platforms, you could do it, but we're like, how often do we use that? Not very often. A lot of projects go by, we won't use these particular properties. Yes, there's an analogous sort of method or property on both platforms, but the idea is we're not trying to create this monolithic cross-platform UI framework. We just want to make it so we can build these apps really fast, and so we can centralize the really important code, the code that actually implements the business rules, that gets the Braintree token and charges the person's credit card. That stuff needs to be in one place. how you actually put all of the little credit card fields and the CSV field, do that on both platforms and get it exactly right. Yeah, so this is the XPLAT controllers. This is right at the core of it. And what we were trying to do here is solve that problem of align the UI view controller lifecycle with Android's fragment lifecycle. We made a decision, and this is probably a reflection of my business partner being more of an iOS fan than an Android fan. We decided that we would just adopt the UI view controller lifecycle that iOS has and not use Android's fragment lifecycle. So the one place where we have had to write a lot of code is to sort of emulate the UI view controller lifecycle on Android. And we do it without any fragments or activities at all. We just have a frame layout, and it's just using the set content view. And we just sort of swap things out and drop them in, and we're monitoring the right events and firing these on view loaded native, on view will appear native. So we're actually using all of the iOS lifecycle event names and that paradigm, but we've been able to implement it in a consistent way across both platforms. And the benefits for us have just been, it's transformed the way we build our apps, because suddenly that difference between, on all of our old native apps, especially when the apps were starting up and you'd have to have like a launch activity here and you'd have an app delegate over in iOS and they fire their events at different times, and some things need to be done on the onCreate method here, and on the iOS version it gets done differently here, and we're trying to initialize crash logging and analytics systems, and it became a real nightmare.
So does that make it easier to build the view models?
Good question. We don't use an MVVM approach. This is very much an old school model view controller. So our models are very light, and they're just the business objects. So they go in our shared code. Generally, they're a one-to-one mapping with the JSON properties of the objects coming down from the API. And then it means there's more code in the controller to sort of, you know, get initialized and get passed in this article object, and okay, so I'll take the title and I'll attach it to this text view here, and the text will put that there, and I'll create all of these other buttons. It means our controllers are doing more work, but because that controller code is shared, because the shared controller code has got references to all of the key UI elements, the benefits of doing that are so great that we can put up with not having very neat view models getting passed in. Does that make sense?
So it lets you interact with the controllers a lot better.
Yeah.
If you were using that model.
Yeah. I mean, one thing we do get, and you can see that here, this is a really simple project, but if I bring up one of our more complicated ones, is all of our controllers get split over 2 files, and all of our views get split over 2 files. So you end up with a lot of files bouncing around everywhere. And you know, you can be working on your iOS platform and you can add a new property in your shared code, and suddenly that breaks your Android version because it's a shared project as well. And that's had an effect on our development process as well. Android lifecycle, this is just what I was talking about, kind of aligning that, that obstacle to really good code sharing in Xamarin. So the benefits are really enormous. I feel like I've covered this, yeah? We've got the same concept that we have for the controllers also extends to the views. So you can see that here in my shared code where I'm creating these views here. Now, one of the things is we've kept this at very much, you're kind of bog standard views. We haven't tried to create a cross-platform calendar view or, you know, an image picker view or anything like that. The idea is that when we implement it, because of the kind of apps we do, the way people want their calendar to work tends to always be different. So we're kind of having to sort of, we're constantly creating that. You can create a custom view, which is again split across 2 partial classes, and it inherits from our X container view, which is a sort of generic view to hold other views. And then you again, you just sort of populate that with your low-level views. You write your shared view controller code in there. So, you know, you respond to a user interaction and you fire an event and let that get picked up by the controller up the chain. Yeah. Again, these XPLAT views that we've got, they're not a common denominator of these two views. They're not a self-contained version that you can drop into the screen on its own. It's really just a wrapper around the native implementation of that view. Yeah, so reusable components. What we haven't done is, like I said, we haven't tried to build self-contained reusable UI components that we use across a bunch of different views. We have built sort of self-contained components that are not related to the user interface. So we've got our own sort of HTTP client implementation, things like location services, a settings store, getting things in and out of the keychain, that sort of stuff. It feels like we've sort of been tinkering with that. That's probably the one part that we keep tinkering with, because we're going, oh, it'd be really nice if we could always, you know, especially those sort of device specific things that are the same across, kind of the same across both platforms. We're really keeping an eye on Xamarin Essentials, because it feels like that's just going to make our little, you know, ad hoc library of helpful little components redundant pretty soon. The one exception to reusable UI components is our alert view. The alerts are such an important part of every app, you know, a little modal thing that pops up in front of the user's face that they have to deal with before they can move on. And the main reason we built this is because we just felt that the defaults in both iOS and Android just failed to create a good user experience. They're kind of ugly and they're really blunt and in your face, and they sort of, you often want to chain a lot of these views. You want to have a view appear, the user does something, and then you want another view to say, yeah, we're processing that, and then another view where they have to choose things. And having these views sort of boom, boom, appear and disappear was really ugly. So one of the things we have done is this, we have built an XPLAT alert view. So I'll show you how that works here when we sort of get some poetry. So up comes this view with a couple of buttons, and when I tap this, I'm going to sort of, it's trying to simulate running off for a second to do an API call, and you can see it just animates the size of the view and it stays there, and it sort of animates the transitions between things, and then it sort of, you know, you can make them go away and dismiss. We've got them cancelable or not, so you can sort of click outside some of the views to make them go away, but sometimes you don't want the user to be able to back out of this, this modal dialog. So I'll just show you the code that's been implemented there. And this code, so there's our alert button there, and it's just got an alert button tapped. And so this here implements everything that you just saw. We create a first alert view, and it's got a handler when the user taps one of the buttons. It gives us the index of which button they've tapped. I'm ignoring that here. I can just sort of create another alert and just call open, and the XPLAT alert view, it's a singleton. It's implemented as a separate window on iOS, so it's right on top of everything, and it will just animate to the new size, and you know, we can wait for 2.5 seconds and then another one comes up. So that's our one concession to sort of cross-platform UI components.
Do you find yourself modifying that with every new app that comes along because someone wants an extra thing in there?
Well, this is sort of the approach we have. We've got a version that works like that. If you just want text, buttons, and the standard 5 states, then it's super easy. And then it's just got a custom view. Okay, and you can just throw in absolutely whatever you want, which, you know, is something they took out of iOS. And one of the versions used to be able to chuck anything in your iOS alerts, and then they took that out. So we felt, you know, sometimes you want a view to come up with a little slider in it, you know, to do something, force the user to do things. So that's sort of, oh, sorry, yeah?
Yeah, how does your code deal with the safe areas in iOS? Like, iPhone 10 or the iPad Pro, but have this concept of safe areas with a notch at the top.
Yep.
So you have to stay within the safe area, can't put elements outside of it. How does your code deal with that? Now you have to check what sort of hardware you're running on. Is it iPhone 8, 7, 6, or iPhone 10? If your new iPad Pro has the notch, so you've got to know which. Do you consider that, or how does it work?
Yeah, it's a good question. I don't know if everyone heard, the question was how do we deal with sort of different device form factors, especially the iPhone X's with their funny little notch. The answer is that because the code that we're creating here is not, it's not trying to be generic. The iOS code that we implement in our iOS project is the same code that you would implement on Xcode. It's just getting transpiled by the Xamarin magic. So we just use layout constraints. We use all of the same things that native iOS developer would implement in Swift, in Xcode. We've got access to all of the same stuff. And this is sort of goes right to the heart of it's a good question because it kind of, it touches on this idea that we're not trying to build something that kind of locks us into, we don't want to lose any access to anything that the platform provides us.
With constraints in iOS, that's the biggest thing. You now have to check the platform, the hardware you're running on, to know whether to use safe areas or not. So you have to do this physical test that if you're running on safe areas, right, that certain elements, certain markers are marked, you can't.
Yep. Yeah, so I mean, we basically do the same as any iOS app developer. We just happen to do it in C# on Xamarin. Because in our platform-specific code, we've got access to everything. We've got some things to make it easier to dig out which version of the device you're running, but they're just shortcuts to what the iOS framework offers. So there's a whole bunch of things that Xamarin has kind of created in our agency in terms of the development process. We used to sort of talk about doing cross-platform development, but in reality, we'd always build the iOS version first or the Android version first, and then we'd sort of port it across to the other platform. And invariably, that second platform never got quite as much love as the first one. Because of this shared code, once you build it on one platform, you've already built 2/3 of it ready for the other platform to implement. So it makes sense. We build everything feature by feature on both platforms. So you'll build the login form, you'll build it on iOS, and then you switch and you do it the same on Android because you've already built all of the business logic, and it's just putting all of the views on the right place on the screen. We actually really encourage our developers, especially when it's one developer working on an app, to alternate even between, for each feature, which one they do first. Do the iOS one first, then do Android. For the next feature, for the forgot password, do that on Android first and then go back to iOS. And one of the things is, once you build it on one platform, you build it on the other platform and suddenly you realize, oh, I'm writing the same code on Android that's over on iOS. I can move that code into my shared files and just save another bit more of that, not repeating ourselves. This prevents the code in our developers. We tried to get away as much as possible from a kind of platform-centric approach. I mean, it's obviously in our team we've got our fanboys on both sides of the fence, but that when we interview developers, and invariably people come to us saying, I'm an Android developer or I'm an iOS developer, and the first thing we say to them is, you're going to be expected to learn the other platform from your first day. So all of our developers now cross-platform developers, and I think this is an interesting kind of mental shift that Xamarin kind of, we didn't decide on doing this. Xamarin led us to this point just because of the nature of the technology. We've got a whole framework for build events as well. Sort of using Xamarin, using the before build event in Xamarin. This gets a bit complicated. I'm not going to try and demonstrate it, but basically in our shared code, we've got this build config file, and part of still in this sort of idea of sharing as much code as possible, we try to have all of the keys that we need, our hockey app IDs, our Firebase IDs, all of that sort of stuff that needs to change between platforms and also needs to change between your build targets. So when you're doing your dev build, you don't want all of your logging data going up to your cloud logging system, and then your test builds that you give to your clients, you want it different again compared to your release builds. So we sort of define all of these constants here, and we just use standard sort of we define these pre-compiler directives. If I open up this, you might not be able to see this here. Sorry. Custom commands. On our before build, we sort of define, this is a debug build, this is on iOS, our preview and our release builds, it comes across as well. Then we've done something here that's really wacky. We've got this one file, this build config C# file. Our before build event calls a shell script that takes this one file, gives it to the mono compiler, which produces a .exe, which it then executes. That .exe reaches into our plist file, reaches into our Android manifest file, and changes all of the build numbers, and it actually changes the bundle ID. And by doing that, we're able to publish our preview builds using an enterprise iOS developer account. Our clients can install that. We completely bypass test flight and it's ridiculous, waiting for your test builds to get approved process. And it also means the apps install side by side next to the live app. So we even sort of prefix our app names with a little emoji. So you can see that here. We stick, I don't have that one there. Anyway, I've commented that out. This is just a bit of fun, and it's just it's not fun, but it's a way that we can have all the code that changes all of these keys in one file in C#, so that our developers don't need to understand the vagaries of using plist in a shell script in order to sort of modify this stuff. Another thing we've been able to do with Xamarin is white labeling. So we've got a bunch of projects where we've built an app and then our clients have got sort of a sister brand, or sometimes we've built an app for a company that on-sells their app to other clients. And we've been able to use the concept of shared projects to split all of this code into code that's shared across all instances of the app, brand-specific skinning code, and then sort of code that's platform-specific on that brand. I'll just show you what this looks like in the file system, and you'll get a bit of a sense of it here. So this is an app we built for Davey, who, they build pumps, pool pumps. So we built an app that lets you control your pool pump over Bluetooth. And they resell, they've got the same pump, it's got a different label on it, and it gets sold under a different name. So we have a white label shared project here. This has all of the core code, does all of the Bluetooth, all of the shared controllers are there. Then we've got platform specific code that's common across both brands. Then we've got a really light shared project here that defines our colors, our fonts, all of the shared images that are specific to this brand. And then we've got our brand specific, platform specific actual iOS project that pulls together 4 different shared projects and produces an app. And it just means it's a bit of infrastructure to set up, but it means we've kind of got where any code that can be shared is shared. And using this build config system, we've got solutions that you can check out and you can build and will just work without any changes at all. Switch to your release config, deploy straight to iTunes. No code needs to be changed. We've also done a heap of internationalization. So we have a shared resources project. You can see that here. we've got our single strings file here, and we just have that set. If I show you my properties here, just uses a public regex file code generator. So the code that gets generated in this automatic code behind is a public class. And this is just straight Visual Studio come out of the box stuff. We're not doing any special coding here. And it just means all of our strings that appear in the app are in one place. And to do our localization, we just add another strings file here with the appropriate locale extensions, and the operating system looks after the rest. We also use OneSky app for manage our translations. If you're doing any internationalization, check it out, because you can upload a strings.regex file, choose which languages you want it in. You invite your translators in. They've got a nice web interface to write all of the different languages for each phrase. You press another button and you get a zip file with all of your regex files already formatted. So there's no more Excel files going back and forth and having to copy phrases out of a cell here and paste it into XML files over there. We've started to take this whole code sharing thing to another level, and we often build the server-side components for our apps. So we'll build the API layer and an admin interface for some of our projects. We've even started to split out a shared project that is just the models, the JSON version, the serialized versions of our models. So it's just decorated with your, excuse me, your Newtonsoft attributes with JSON property names. We can define our own serializers for date times and money classes, things like that. And then that project is actually used in our server-side solution, ASP.NET MVC core project, handling its incoming API requests. The same code is then used in the app at the other end, and when it gets an object out from the RESTful service, reconstitutes it with the JSON, and you've got those same properties in the same place. We're still on the fence. It's super elegant, but we're not sure if it's actually worth the hassle of having all of these separate projects.
So do you have one repo for both app and server backend? Do you have two repos?
We'll often have a separate repository for the shared project. So we'll have one repository for our API server code, and then a separate repository for the shared code, and then a separate repository for the client-side app code. And both of them just, the SLN files, because it's all Visual Studio, it's all C#, just goes up a couple of steps in the tree. Just make sure you name your folders the same when you check them out, and it all works. So that's how we leverage Xamarin and how great it is. I'm just going to touch on, we're already at 7, just going to touch on a couple of the challenges that we found using Xamarin. Now, I'm probably talking about this very much from the perspective as coming as a native app developer. I think somebody trying to come at this sort of stuff from a web development background might have a different perspective. By far the biggest problem is that Xamarin there are not third-party libraries for, there are not Xamarin bindings for lots of third-party libraries. Microsoft does a good job with Google Play services and a bunch of the really big things, the Firebase stuff, but you grab some chat soft SDK from some startup in San Francisco, there's an Android SDK and an iOS SDK, but there's no way to drop that into your Xamarin project without creating your own Xamarin bindings. We've got good at creating Xamarin bindings. We've done that for a bunch of things. We did it for Vuforia, which is a really big augmented reality thing. So we created our own Xamarin bindings around that, so we can use Vuforia's AR in Xamarin Apps. But it takes time. It's a specialized set of skills. It's something we've only got one guy who really knows how to do it properly, and it just slows us down. And it's another reason why we try to avoid third-party dependencies as much as possible. The developer community for Xamarin is just a lot smaller. It's not quite as popular, which means there's less answers on Stack Overflow for the stuff. It is harder to find staff that have Xamarin experience, but we've actually had our best success just hiring app developers who've done native code and teaching them C#. C#'s an easy language to learn. It's the cleanest of all, if you ask me. And it's much easier. It's much harder to learn the framework than it is to learn the language. Comparing that to getting a .NET developer and asking them to learn how to build apps, that tends to be a lot harder for them to wrap their head around. We have issues with the toolchain. Some of the publishing in Xamarin we've had problems with, but to be fair, I've had just as many problems publishing things out of Android Studio and Xcode as well. But I guess the one thing we do find is with Visual Studio, there's just a bit of a lag. A new version of Xcode comes out, a new version of Visual Studio will come out, and for the first couple of weeks, it's just a bit more buggy than the new version of Xcode. So that's something we've found, but it's actually getting a lot better, and things do seem to be getting fixed a lot faster. It's certainly, I think, when it became from Xamarin Studio to Visual Studio, that was a big improvement. It brought all of that stuff, all of that beautiful IDE goodness that Visual Studio has developed over so many years into that environment. Oh, and some of the profiling testing tools, we're sort of comparing some of the Xamarin profiling tools to instruments in Xcode. It's not quite there, and it's quite expensive. One thing we have found really good with Xamarin though is we use Hockey App, which is now App Center, for our crash logging, and the stack traces we get out of our Xamarin projects are generally far easier to parse and understand than our Swift stack traces. I've got a few case studies, but I think I might just skip over those because we're already at 7:05. Yeah? Has anyone got any questions at this point, though, before I just start boasting? Yeah, down the back.
Hi, sorry, I missed the start of your talk.
Oh, let's go back to the beginning.
I just wanted to understand, I don't know, maybe you've explained it already, but I just want to understand your reasoning behind why not choosing Xamarin Forms over growing your own XPLAT, and what sort of specifications you made.
That's a very good question, and I had a heated discussion with my business partner about this exact thing earlier. It's really driven by this. I think it's partly cultural, because we came as native app developers. We already knew how to build our apps exactly as we wanted them in Xcode using the iOS framework and in Android using the Android framework. We didn't want to have to learn a new framework with its own XAML layout engine and all of these new names for all of the text fields and the buttons and all of the objects that we already knew how to use. We just sort of thought, we already know how to use that. We don't want to take on another platform. I guess the other angle on that, and it's, these were decisions we made a couple of years ago, but there was a feeling that Xamarin Forms was an excellent tool to sort of get an app out the door quickly. You can put together a great form, you can do all of your business logic, and you can get that app out the door, especially if it's an internal tool, it's quicker. I think Xamarin Forms is quicker than our approach. And most of what we do can probably be done on Xamarin Forms just as easily. But with the kind of apps we do, it's that 5% of functionality that Xamarin Forms isn't going to give us out of the box. And suddenly we're having to sort of work against the framework that we've built our whole app on in order to sort of, get this text field to behave in this really weird way that we have to implement on each platform specifically. So our approach, it uses more code and it does take longer, but it's all about just being closer to the metal, if you know what I mean. We want to be as close to that existing framework as possible. There's enough layers in IT already. We didn't want to add another one. It's the same reason why we don't use React Native. We don't want another layer and another interpreter in the mix, turning this code, interpreting that, which then gets turned into something else. The real magic for Xamarin for us was that it sort of took your code and it transpiled it, and what came out at the other end was indistinguishable if we'd written that app in Xcode in Swift. it's the same binary, roughly, you know, I don't know exactly, but it's as close as, it's all just native objects under the hood. So it's partly cultural, I think, from where we came from, but there is ideas behind it. Maybe my ideas are a bit misguided, but yeah, that's where we're at. Yeah.
Would you ever open source XPLAT or any of your bindings?
Yeah, we're certainly keen to open source our bindings, because that just feels like, you know, we did the effort and we put it together. Open sourcing XPLAT, it's kind of our secret sauce at the moment, but it's something we're talking about because it feels like, you know, we're just 10 guys in Collingwood. It's not like, you know, our intellectual property is going to get stolen by somebody else and we're going to run out of business. It's something we're thinking of. Part of the reason we're hesitant is, you know, as soon as you open source something, everybody expects you to support it. Especially with our bindings, we'll only bind the bits we need. We only need to do image recognition and playing videos on top of our recognized images in Vuforia. We didn't bind any of the 3D stuff because we're not using it. And if we publish that, people are going to be like, hey, this is great, but can you please give us a 3D part? And we've got enough apps to look after without having to. We would like to, but you know what it's like when you use a half-finished open source project? It's kind of like, you know, there's another, I think there was another question here.
How would you deal with Apple and Android that has specific like machine learning APIs that you can start using? Obviously, you have to have a very specific app for using this, but clearly, whenever a new SDK or API comes out, Xamarin tends to lag behind, because unless you use the stuff natively, you have got access to it. The Xamarin bindings aren't there, so Microsoft hasn't. But usually, let's say Apple bring out a machine learning API. They have that recently. Now, if you want to use this, well, it's there in iOS. Android probably is it's something similar but different.
Yep.
So how do you deal with that using that in Xamarin? So how do you have to drop down to native forms, don't you? Well,
if it's something that's been published as part of the Android or iOS framework, the core frameworks, we kind of trust Microsoft to keep up. And they've been pretty good at that in terms of, you know, speech recognition. You can, all of the text to speech and speech to text that you get through Siri, that's all there in Xamarin.iOS. We trust Microsoft to keep Xamarin.iOS in sync with the iOS framework, and similarly on Android. We're yet to sort of find a bit that hasn't been implemented correctly. Since Microsoft took over Xamarin, we found a lot fewer bugs. We still sometimes get some really weird just things that just don't work in Xamarin for God knows how, and we've had to work around things. But if you're talking about sort of SDKs that have been published that aren't part of the iOS framework and Android framework, that's when we have to write our own bindings. Yeah, that's when we have to write our own bindings. But say, you know, speech to text, that's implemented on iOS very differently than it is on Android, I assume. We just have to do that in our platform-specific code. And that's, I guess, why we're very much, you know, it's a shared project and the platform-specific stuff happens over in that part. And yeah, we end up writing code to do the same, achieve the same goal. We have to write it twice on each platform. But, you know, we'd have to write the whole app twice if we were using Android Studio and Xcode.
Studies or metrics as to, let's assume you have a common, let's assume you put your backend code into, say, C++ library, and then just use native Android and iOS as a thin front end. If you use that approach, I'm not sure whether you've ever done this, but what's the saving in time in terms of, well, let's talk native Android, iOS, and then Xamarin. Have you done actually a metric to study how much time are you actually saving, considering sometimes you have to do workarounds with your work? For all your projects, instead of clear, 20% faster, 30%, that's really what everyone wants to know.
Yeah.
The technical stuff is great, but that's the
the questions around, do we have any metrics on how much time we've saved with this sort of approach? No, we have next to no metrics. We're too busy trying to meet deadlines. But yeah, but you know, anecdotally, huge savings. It feels like we've had much greater savings. The things that have really, there is a bunch of problems that we've solved using Xamarin that are just so clear. The subtle differences in the UI implementation back when we're using native code, because the iOS developer formatted their dates with a leading 0 in front of the day numbers, whereas the Android guy didn't. All of that stuff, all of those little differences between the platforms have disappeared. If we get a bug on one platform, most of the time it's also on the other platform and only needs to be fixed once. Not always, of course, but yeah, it does feel like we've had huge savings. It certainly meant it's also meant that sort of tail of our projects where we're fixing all of the things. You know, we've delivered the test build to the client, and then there's those 3 weeks of fixing things, which often stretches on and on and on. That's really shortened because there's not this sort of weird platform-specific bugs. Kim?
I'm guessing in terms of runtime performance, using your approach would be actually very good because you don't have a lot of abstractions, but pretty much run on metal. Is that true? It's pretty good.
Yeah, I mean, like I said, the whole XPLAT framework that we've built, it's kind of just sugar, you know, around the native objects. We're not sort of doing deep reflection or anything like that. By the time it gets compiled, you're really just dealing with the native objects under the hood. It's certainly not something we've noticed. You know, the kind of hit run, how long does it take to appear on your app? That's always an issue for slows developers down, but that's an issue across all of the platforms. And the one thing we have found is we do have issues when we've encountered issues with the linker on Xamarin. Linking out the frameworks that you're not using. Do people know what I'm talking about? Sometimes that doesn't work because we're using some reflection or especially a third-party framework's using some reflection, so you can't reach in and decorate it with attributes to say that it has to be included. And we often end up, we've had this experience where we build our release builds of our Android app, we link out everything we don't think we're using, we deploy it on our builds from the Play Store, and it just crashes on launch. And we end up having to switch the linker off, and we end up with 60 megabyte apps. They run just as fast once you've downloaded them and they start up. But interestingly, not so much. I just did a release today, and linker worked fine, and that was a really fancy one. Yep.
With your white labels, are you concerned about Apple's announcements that they don't like white labels, and they'll be pulling apps from the store if they're clearly actually the same app? So my position on it is I'll keep doing it as long as I keep getting away with it. Yeah,
I mean, I'm generally, am I concerned about, I didn't even know about it, you know, but I wasn't concerned until now. But look, in general, I'm actually support the Apple's app review guidelines. I generally don't sort of have a problem with Apple imposing all of these, you know, annoying rules. And God, I mean, I've been meaning to write a blog for years called Dealing with Rejection, with all of the reasons my apps have been rejected over the years. I mean, some of them just so many times. You know, what are Apple trying to stop here? They're trying to stop people who publish 100 apps that are all the same, but for the, you know, a slightly different skin in order to sort of, you know, maximize their ad revenue potential. And, you know, yes, stop those apps. They're cluttering up the app store and they're a scourge. Let's get rid of them. But if we publish an app that's, you know, use this app to connect to the pump that you just bought with Davey written on the side, and that one's got something else written on the side, I think they'll be fine with that. One thing I have found is when I do get my apps rejected, and I've had clients, we've had projects where people come to us saying, we've finished our app, but it's got rejected, and my developer has just walked away because they can't deal with Apple's bureaucracy. A really calm, well-written, clear, friendly message through your Apple Rejection Center has solved so many problems. Most of the time, you just have to spell it out. There's a real person at the other end, and if you can just state your case clearly and calmly, and unless you actually are in contravention of the guidelines, you'll generally get yourself through. Anything else? Oh, yes.
I don't want to.
Yeah, go for it.
Do you look after all the deploying to App Store and stuff for the clients, or do you kind of hand over the code and then?
No, we generally do all of that, and that's my role as at my business. I don't write too much the actual app code myself, but I am what we call our release manager, and it's a very specialized set of skills. You know, it's as much like a consultant. You know, it's like a conveyancer. I always think, you know, that they don't actually help you buy the house; they just fill out the right forms for you. So it's a hell of a business, you know. Don't ever publish to production without checking it on test flight first. That's my advice. Use the internal test track on Google Play. So all of our test builds, we publish through App Center, Hockey App. We sign them ourselves, but our release builds, we use test flight and Google Play's internal test track exclusively for testing our release candidates. So we put them there first, we load them, we check. Most of the time, if they're broken, they'll break straight away. Sometimes they don't. But yeah, it's a real business, you know, and just getting all of the icons and making sure you got all of the privacy plist settings and doing your notification channels on Android 8, otherwise it won't get push notifications. Yeah, it's a nightmare. But that's the nature of the technology that we're working on. And the good thing is it's so complicated, you will get paid just to fill out forms on the internet. Anything else?
I was wondering, so you're using like an MVC type of app.
Yep.
Do you use dependency injection, any of those frameworks? You don't do any binding. Any other libraries or frameworks you use?
We generally no. No, the third-party frameworks we use. Look, I'll bring up a real project. Let's look at something real. This is an app we just built for climate scientists at Monash University, so you can report extreme weather events. When there's a flood, because apparently the radars and the rain gauges, they don't actually show that stuff. So while that's building, let's have a look at what packages I've got. So this one's got Mapbox, which is solving a problem that's really hard to have gorgeous maps. We're not going to try and write that. We use Serilog for all of our logging. Again, it's something that solves one particular task. We'll often use frameworks that handle loading images off the internet because you know you want to store it in your response cache and a memory cache version, and then you know have all of the right things. You don't want to show a loading image if you've already got a local copy, and then you want to replace it. All of that sort of stuff. Yeah, but not much else. And then a few little packages of our own. And this is, you know, this is a nice little app. Has there been any? Oh God, I can't see anything there. It's too dark. Oh, I don't have any internet. Well, that's gonna fail, isn't it?
It didn't explode.
Yeah, but it didn't say we can't connect to the internet. Anyway, Yeah, so really no. We really try to avoid those third-party frameworks. And, you know, stopping third-party frameworks creeping into your apps is actually more of an HR issue than a technical issue, because some developers love to just chuck them in. And we've actually had a lot of success. We often hire very junior developers and train them up in our way of doing things, because we do have a pretty specific way of doing things, which is a bit different.
What size would that app be if that's your average number of extra packages? What kind of size is it when it's a compiled package that's being distributed? Are they talking 10 megs, 100 megs?
Oh no, like less than 10 meg generally. The things that the really bloated apps are the ones that want to like track everything, you know, the crazy egg and all of the Facebook install tracking. It's analytics and marketing. That's where your bloat is. We built the apps we build that are like really, you know, if your app displays ads, it's going to be massive, because those things just too much code. If you're using some third-party framework that can throw up a full screen ad when you get a push notification, like what was that, Urban Airship was the big one back in the day. Those things are really big. Generally the third-party frameworks, if the third-party framework's putting pixels on the screen, it'll usually be far bigger than if it's a kind of something written for developers to solve a task.
I think we should finish there. Pizzas have just arrived and Tim's busy setting them up. Thank you very much, Mick. So everyone put your hands together.